Okay, so welcome to this lecture number 7. So basically, we have gone through so many already, but today we will look into the document, especially on the formatting and also some properties lah. So the reason why we need to understand the structure of the meaning of the content of the document is that because when we try to retrieve the document, we need to know the structure. We need to know what is the content of the document so that we can at least manage the document. So for today's lecture, we will go through some of the property or some of the format that we need to look into when we look at the document. Okay, and finally, at the end of the lecture, we look at those process involved in uh, pre-processing the document into vocabulary. So how do we tokenize and then how do we make a vocabulary out of the document that we have? Because the quality of the input that we put into the system will also affect the accuracy and how efficient is the information retrieval system that we have. Okay. So for this one, let's take a look at the outline. So we will look into four items: metadata, referring to information about information. So whatever information that we have, we also have the information about that particular information. And we look into the document format, what are the property of text, and then lastly, we look into the stages for pre-processing document. Okay. So when we look at the data, let me minimize this one. So when we look at the data, we look at the syntax or the structure and also the semantic. So the document is referring to a single unit of information. So they have syntax and structure. So similar to your programming, when you do programming, when you do some mistake due to the syntax, so it's referred to the grammar of the language. Right? If you learn C++, if you learn Java, and you learn Python, they have their own syntax or grammar. So each document will have their own structure and also the syntax or the grammar of the content that you have. Okay, so syntax and structure referring to the grammar and also the structure, the formatting of the document. We also have this semantic refer to the meaning or the content that we have in the document that we have. So this is important because if you want to cluster or if you want to classify a document, we need to know content of your document. So it refers to the semantic or meaning or concept that can extract from the document that, or every document that we have. So in order to display the syntax and structure, we may have a presentation style. So they will give you the structure, the style, and also it depends on what kind of document that you have, and then how you display or print the document. So as you know, books will have different format. Your CV will have a structured format, or a journal or conference paper, they have their own format, right? So when we talk about the document syntax, basically we look at the structure, presentation, and also the semantic. How the syntax, the grammar carry meaning, because the grammar of the sentence can tell you the meaning whether it has done in the past or will happen or is happening at the moment. Okay. So document syntax refer to the grammar. So you have this document, you provide the syntax. So it could provide you a syntax referring to how you present the document, the format, and the structure, the formatting again, and also the meaning. So the syntax could contribute to one or more elements. So for example, one syntax can affect the style of presenting and also the semantic of the document that we have. So when we talk about the document style, it's basically what we have in the journal that we have or textbook. So for example, you have the chapter name, we have the title, we have the introduction section. So normally when you want to do work or you want to submit your work, you always ask, do we have templates or do we have any format to submit? Because in order to understand what message you want to send across, you need to know what formatting you need to follow. Okay, so you do not want to have the conclusion to be written at the beginning of your document, or the introduction part is presented at the end of the document. So you must follow the template. And one of the tools that they use to do formatting, this is for scientific document. Scientific document, they use this what we call LaTeX. Okay, this is used for scientific um, documentation because they have very complex formula, and it is very easy for them to use LaTeX to formula, how to write a complex formula and so on. Okay. So this is the example of LaTeX. So on your right hand side is the screen telling you that introduction is just a section and the label is called section introduction, and we have citation label and also we have percentage. So when you run that one in the LaTeX, so it will give you this more appealing presentation. So what we have at the moment is we have all the citation here and citation. You can change the citation style here. So whether you want to have number or you want to have author with year and so on. So if you want to write your FYP, I recommend you to use the LaTeX. It is easier to manage the tables, easier to manage the figures, citation, section, and everything. It takes time. For me, for you to learn LaTeX is only 1 week is enough. You need to invest time. Okay, so we talk about the query in relation to the document that we have. The query can be considered a short piece of text, so differ from the normal text. So understanding term is very important. So that's why you need to have the background knowledge of certain topic that you are looking for. Okay, so if you have no idea about that particular topic, then you don't know what to put up, what to post, what to query. And and at the same time also, if you just put a query just bank, then the system have to differentiate whether you are referring to Bank of River or bank account. So this is part of the study that you may already study in the natural language processing, in which each term will be analyzed based on the context of the other word that exists in the same sentence. Okay, so you look at the lexical analysis, the relation between one word and the other word in order to determine the meaning of that particular term. So not simple to infer user intent behind a query. So unless if you analyze the whole um, terms that they have posted in the query. So now we look into the first one, metadata. So basically, this is the information about the information that we have. So for example, this is just an analogy. Okay, for in database, you have taken database management, right? So you learn about the relation, the tables, the attribute. You have the primary key, you have the composite key, you have the indexing. What else you have? And many more. So all this will describe your database. When we compare to text document, normally in text document, we want to look at the document in terms of who is the author, when did the text document publish, and then who is the publisher, and then the number of pages, and then what is the content of that particular document. So all this must be extracted from the text document in order for us to manage them. Okay. So long time ago, we do not have a powerful system that would be able to store all this information, but now we do have. Okay. So last time we used this catalog card that consists of all the information required by a librarian. Okay. So you ask the librarian, where is this book? This is the title. Where can I find the book? Then you have to ask them. So if you know how to find the information, then you have to look at the catalog card book. So this is what it looks like last time, but now we use a system. So when we talk about the semantic, okay, semantic referring to meaning, right? Or concept or meaning behind the document that we have. So for each of the document, we need to know the content of the document for us to manage them. Okay, so we need to characterize, we need to classify them. The document belong to what subject, what subcategory. Okay, so in order to do that, we do have the natural language processing. In data mining also, we have clustering in order to manage this document. Okay, and last time they do have this machine readable cataloging record. It most used format for library record in the States, so it looks like this. So they give you the main author, the title, and so on. Okay. Okay. Due to the increase of the web content nowadays, the difficulty is to say who owned that web page, who when did the web page establish. So we need to have this kind of information. Mostly because we want to do cataloging and the content rating, because we want to index all these resources so that easier for us to retrieve later on. Okay, and also for the intellectual property right, because some web page contain exclusive property right, so they do not want you to copy, or they want to say that that idea belong to them. So we want to have this intellectual property right documentation and also digital signatures to say that certain website belong to specific individual. Okay, and of course the third one is application to e-commerce, in which we have a lot of data inside e-commerce page and also all the transaction that we have, and buying, selling books, and so on. So the initiative to create or to add metadata information to web page has become um, more required than in the past, because we every day we have new pages, we have new resources, so we need to document them. So one of the way for them to document is they use this RDF, resource description framework. They use a tuple document. So this is new standard for web metadata. So they use tuple, but before that, we need to identify this node. Okay, so normally when we look at the web page, we look at from HTTP to the last file that we have. So basically, we are looking at this one until here only. So that one is your URL. But now the web page or the address that we have, they have some more here. So that one is considered as the URM and uniform resource name. So together this one become the URI, which is the uniform resource identifier. So the URI tell you who is the owner, who is when did the page establish, and then and so on. So how do we document this? So they use the RDF. So they consist of the resource, properties, and statement. So the resource telling you all the things that being described by RDF. What kind of resources are we talking about? Web page. And what are the property that we are talking about? Okay. For example, the author, or when did you publish, or when did you create. And this statement will put up the specific resources together. Okay, like this web page, who is the main author, and then when did you establish that web page. So for example, we can have this three tuple representation. We are saying that, okay, this resource have property type and the value is that particular value. So when we have this web page and we have this property, the property is author. So Jane Sarela is the author of that particular web page. So we can use this to document the web page. So this is what we call the resource description um, framework. Okay. Okay. So we can learn more about this. There is one course that are dealing with this. They are called semantic. So have you heard about semantic web? So semantic web meaning that you can get the meaning of the web by documenting your web page like this. They have this taxonomy. So, but we will not go into deeper about semantic web. We just want to know how web page is being documented. So they use the RDF data model three tuple representation. Okay, now we go to information theory. This information theory talk about how much information that a certain term can carry. Okay, so we want to know how much information that is being carried by a single term. Okay, so, for example, a text where one symbol appear almost all the time does not convey much information. So this is what we call the stop word, right? So they are saying that terms that always exist or more frequent exist, they are carrying less meaning. This is what they call the stop word. So in the more frequent use, then they say they will carry less meaning. This because due to the entropy that we have here. Okay, so information theory define a special concept entropy to capture information content. So what is the formula for this? So the entropy is defined by the log 2 base 1 over the power of the probability of having that particular symbol to exist. Okay, for example, this is the text that you have. Okay, and this is the average entropy for all the term that you have here. Okay, let's take a look at one symbol. Okay, we focus on this one only, not that one, because we do not want to have the sum, right? We want to have individual calculation only for this particular item. So when the probability of having that particular symbol to have the probability is 1, that means that symbol exists almost every time, right? Do you agree with me? If the probability of having symbol I is 1, that means that symbol is always there. So they occur more times than the other term that the other symbol that we have. So when an item occur more frequent, so this one will become log 2 1, right? So when this is log 2 base 2 1, this is 0. So that means the entropy is 0, meaning they capture no meaning. They're always there. Okay? So meaning that term or symbol that occur less or appear to be less number compared to those terms that always there carry more meaning compared to those terms that always there. So that's the idea here. So how do we apply this? How do we apply this? Because this is average. Just take a look at the close example here. So for example, we have this one, University Malaysia Sabah. Okay, and let's suppose we have this 23 symbol only. So this is the probability of each symbol that we have in that particular closed model here. So the probability of U is 1 over 23. The probability of A is higher lah. Okay, so when we look at S, so S we have 1, 2, 3. So 3 over 20. Okay, A also have more. 4. Okay, that is the probability. So if you want to find one term, the entropy of one term, so we will say, okay, the entropy for this university, so we just add up the whole total here and divide by 10, because in university we have 10 symbol, right? Basically, yeah. So we will go each one of them and then divide by 10. So finally we have this. So this is the entropy value that we have. So the higher is the value, the better that you have, right? Okay. So that's how you compute the entropy. Zero meaning that they carry less information. Higher than 0, maximize the value will tell that term carry more information. Okay, so this is those who have taken data mining or machine learning, then this is what you used last time. So they simplify this one. So the entropy now will be the summation of all the classes or term that we use in a data set. So this is the probability of having that particular symbol in your text. Okay. Okay. So this is sample of question. So just now we have gone through university. So your task is to find the Malaysia and Sabah. Okay. So when you have free time, you can do this one. So now we go to modeling natural language. Just now we have gone through metadata, and then we have gone through, let me go back to the first slide. So metadata, and then document format, and text properties, and last one is document preprocessing. So we will go this one first. Okay, so we're done with the document format. Okay, now we go to modeling natural language, okay, text properties. So we try to process the document. We assume that there is a symbol that can be used to separate the word, and also a symbol that that become part of the word. For example, in this example, we are saying that the blank space here is used to separate the document. And we say that non-blank will be part of the term that we have. So different word will have different distribution, right? So some would appear more, some would appear less. So they have this model in Zip law, are saying that this law states that the frequency of the I most frequent word will be given like this, which means that they say that, let me, they say that the F1 is the frequency of the most frequent word, and this alpha is just 1. So this is 1. Okay, so this is the most frequent word. Okay, but when we want to find out the second most frequent, that means we have F2 here divided by, oops, so this is 2, so this is 1. So what we are saying that here is that the frequency of the second most will be half the first one. So if we take the third one, so this is 3, then F1 3. So that one, the third most frequent item will be 1/3 of the first one, right? Okay, so that means you will have a slope saying that you will have most frequent, and then followed by the second one, and then third one. As you go to the fifth and sixth one, they will the frequency will be lower. Okay, so this is just to show that how do we get the frequency of F1. So this is how we get the frequency of F1 lah. So the n refer to the number of the n word, okay, and then this is the summation of 1 over 1, and then 1 over 2, and so on, so on, so on. So you will have this F1, the value of F1, then you can gantikan di sini lah. So the summary is they are saying that assume that we have the most frequent term, which is F1. The second most frequent will be half of the first one. And the third one, the third most frequent will be 1/3 of the first one. Then the fourth one, they say it will be 1/4 time of occurrence that we have from the first one. Okay, so we will have something like this. So they say that okay, only a few would having high frequency, and most would having low frequency. So coming back to the statement that we have at the moment, where we say if that would appear almost every time, so that means they are here, right? so less meaningful. So if they appear to be less, then they are over here. So this gives us a chance to reduce our data set. So we focus on only that appear on the right of the graph. So the threshold here is up to us lah. So we can investigate how fast they're processing and how accurate they have. So you need to tell what is X here, the boundary lah. Okay, and since the stopword is almost here because they are always the occurrence of stopword is high, so they are over here. So since they're saying that they occur many times, so they will be removed because they carry no meaning, less information. So that is the stopword. And also we have this text size saying that okay, as the text size or the number of alphabet is increased, we have this graph will be here because what they're saying that the number of vocabulary that we can produce as the text size is increased will be getting smaller, smaller, and smaller. Okay. For example, like this, if the text size is 3, so we can produce this vocabulary, but if we increase by this amount, then we have this number of vocabulary. But when we reach here, so it almost that when we have long symbol that constitute the word, we will have less vocabulary. For example, if we look at this one, okay, so this is a sample of word that has 28 letters, 29 letters, and the longest one is 45 letters. Okay, and the meaning is just like, for example, the 45 letters, suppose lung disease. I'm not sure how to pronounce this, but this is the record, the longest English word. So when you have number of the size of text increase, that means the number of vocabulary that you can produce is only limited. Okay. And now we go to the text similarity. How do we measure the text similarity that we have? Okay, the first one is the distance function. Okay, this is for string of the same length. So the requirement is you must have string with the same number of symbols. So the distance between them is the number of position with different character. So you just identify how many character which is not the same. Okay, if all of them are the same, then the distance will be 0. If all of them are not the same, so it will be the number of symbol that they not match lah. So this is what we call Hamming distance. Okay, so very straightforward. The next one is sometimes they use the number of operation to modify them. For example, this is what we call the edit or Levenshtein distance. Okay, the distance can be measured by how many operations you need to do in order to match them. Okay? So, for example, the color and the color, so the distance is 1 because we need to delete or we need to add U. Delete or add U. So, one operation. Okay, for the survey and surgery, so the distance will be 2 because we can substitute V with G and then delete R. And we have 2 operations, so the distance is 2. So the edit or Levenshtein distance depends on the number of operations that you need in order to make the two terms to be same. And also we have this longest common subsequent. We are looking at what are the symbol that has similar sequence in both terms. So for example, the longest common subsequent for survey and surgery will be survey. So the value will be 5. So the longer they are, the more similar we have for both terms that in the example. So this is called longest common subsequent. And the last one is the resemblance measure. Okay, the resemblance measure looking at the content of two documents. Okay, so the resemblance formula are defined by the intersection of two documents, intersection of common term, divided by the union of the two documents. Okay, so the intersection here, they try to find common term between these two documents, and then the union here referring to the combination of unique term that we have from document I and J. So if they are the same, if DI and DJ is the same, so you will have 1, 1. Meaning that if the content of DI and DJ, the common term that we have is 10, and also the unique term that we have for DI and DJ is also 10, then we have resemblance 1. And the distance will be 1 minus the resemblance. So how do we apply this formula? We look at the example here. The first thing that we need to do is to list all the unique terms that we have for each document. So document 1 has 4 unique terms. Document 2, we will have 7. Document 3 will have 6. Document 5, we will have 5. So when we look at the resemblance measure for document 1 and document 2, okay, so document 1 and document 2, so we are looking at the similar symbol first, then this is 2, and when we join this one, union of this, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, so 9. So that's how we get this one. Okay. So similar to document 1, document 3, document 1 and document 4. And when we want to find the resemblance, so we just subtract the 1 minus. So this one is 1 minus 2 over 9. So based on the resemblance that we have, so this is 2 over 8, and this is 1 over 2 over 7. So very straightforward. So this is very useful when you want to look at the similarity between two documents. So it means that the order will not be considered here. So we look at the term only. Okay, last one. Okay, looking at the metadata, looking at the text properties. So we look at what are the document pre-processing that we need to do in order to form the TF-IDF. Okay, remember that in TF-IDF, we supposed to have a list of unique terms that represent each document that we have. And then when we accumulate them, they become list of unique terms, or what we call vocabulary. Okay, this is the pre-processing that we have. Lexical analysis. We eliminate the stop words. We perform the stemming to find the root word of words that we have. Selection of index term or keyword, and then finally we construct the thesaurus. Okay. So what happened in each of these pre-processing? In the first one, lexical analysis, the process of converting stream of character into stream of words. So in other words, we call it tokenization. We produce tokens of term, and then we push to the next stage. Okay, so we identify words in the text. So we use the blank space to separate the would, and also non-space to say that that symbol belong to that particular would. So this is what we call tokenization. So we use the space, number, hyphen, punctuation marks, case of letter in order to tell that this wood that we can extract from the document. Okay, the stop wood. This is the what? The wood that appear almost every time. So almost every time. So we want to remove this. Okay, so we want to remove this because this will take a lot of computation time because we want to compute the TF-IDF, right? So we want to remove those words that carry less meaning because they appear the most. Okay. So reduce size of index by 40%. So even some will reduce up to 40%, up to 50%. And the next one is stemming. So stemming referring to reducing the number of terms based on the root word that we can produce. So for example, connected, connecting, connection, all can be reduced to a single term which is called connect. Okay. So if all these connected, connecting, connection all exist in the document, so we can say that the term connect exists 3 times in the document. So this is to reduce reduce size of the index, so it will reduce the computing process. They mention here that many search engines do not adopt any stemming because when you remove the ing or ed, io, and so the meaning gone already. Okay, because when we remove the ed, the ing, so we don't know whether in the process or past or something else. Because in natural language processing, we need to have the actual term and then how this actual term is related to the other term in the same sentence. Okay, and then we go for keyword selection. We only look at certain keyword and then the nouns. For example, with the science, iOS, Angeles, and so on. So this is just to produce the list of relevant keyword that we want to store in our vocabulary database. Okay, so these are the final diagram where we perform the lexical analysis, stop word removal, stemming, then we do the selection, then finally we have the final taxonomy of keywords that we have from that particular corpus of document. So you see a lot of process that we have. So maybe you learn this one in NLP. This one you don't have to learn. You just look at the statistics. This one also there is a study on this on how do we perform stemming for English or even for Malay language. Okay, so contohnya if makan, makanan lah, or dimakan, or um, dimakankan. So all this coming from the root word makan. So there is a research on how effective is the stemming for Malay because as far as I know there are some error because sometimes you over prune them or under prune them ataupun in Malay we say lebih potong atau terkurang potong. So in Malay language we do have certain area to be improved and also keyword selection and to construct the list. So from the list then you can say okay I have all the term that I have, term 1, term 2, and so on. So we have document 1, document 2, and so on. So from this, we construct the matrix and we compute the TF-IDF. Okay. Okay, so that's all. Any question? Any question that you want to ask, you can ask me.
No question, Doctor.
Okay. So looking at the difficulty of your